cover the concept of Mac move. If I talk about what is Mac move, it is simply a MAC address which was learned previously on a particular port. Now the same MAC gets learned onto a different port. That is what we call it as MAC move. So in this section or lesson, we will cover the concept of MAC move. A MAC move can happen when there's a loop, or it can happen in some other conditions also. I will demonstrate it using a simple topology when a cable is disconnected and moves from one port to another. Okay, and then we will see what else could be the interview questions related to MAC move. Okay, let's get started. So our topology has been like this. We have a switch S1, and we have a hub connected to the switch, and then there are three PCs connected to the hub. And then we have this MAC table for the switch S1. Now, if we say PC3 wants to send data to PC6, it creates a frame and sends it out. Okay, now switch does its steps for processing the frame. First step, looks at the source address field, which is C, doesn't find it, populates the MAC table. Okay, so MAC table C is learned on port P3. Next, if in this case, I'm not going to go to the next step for what would the switch to or flood or forward frame, because we are trying to keep the focus on the concept of MAC move. So after the first step, I have paused, and then we are moving to what would happen if I disconnect the cable from here, right? This one. So if I disconnect the cable from this cable from the switch, what would happen is basically the MAC address from the MAC table would get wiped out, because this is what is the property of the as soon as the port, because when we disconnect the cable, this port will go down, and as a result of that, the MAC table will delete that entry. So this is expected. Now, to explain the concept of MAC move, I'm going to modify the topology a little bit. Right? This was our topology. What I'll do is we will introduce another hub here. Right? I'll take out the PC3 and put another hub here, and then connect the PC3 here, and then add two more PCs here. Right? Okay, so now our topology has on the port P3 of the switch, a hub is connected, and then there are PC3 connected here, and PC7 and PC8 connected here. Okay, and now let's make the this is the modified topology for us. Now what do? We do the same thing. Ask the PC3 to send data to PC6. Okay, it sends it out. The hub floods it. Let's just focus on the frame that arrives on the port P3. Same thing. MAC address C is learned on port P3. Okay, this is what will be learned. Good enough for now. So the MAC table gets populated. Good. Next thing is, now if in this case, if we disconnect the cable between the hub and the switch, again, hub and the switch, if I disconnect this cable, this port P3 will again go down, and this MAC table will, and this populate, the entry will also get deleted. Okay. So if I delete it, then the MAC table again clears up. However, instead of deleting this particular cable, if I disconnect this cable, right, then what happens? Right, in this case, the the indirect cable is getting disconnected. This cable is still in place. So this port will not go down and hence this entry will not get deleted. So in this case, the entry still remains there. So our MAC address still appears to be learnt on port P3. Good. Next, what I do is, if I will remove this PC from here and move this PC with MAC address C in place of PC5, my topology would something look like this. Okay. Remember, this was like this. I removed this PC and then moved this one from here to here. This. Remember, right? The MAC entry is still here, showing that C is on port P3. And remember that entries in the MAC table get learned or get added when a switch receives the frame. So unless this one, so so this is what has happened. So now if this PC sends the frame, then only this switch will learn it on a different port. Now let's go through it. How will it happen? So it is moved here. Now let's say PC3 wants to send data to PC6. Okay. So it again creates a frame, destination address F and source address C. Now the frame is sent out. This hub floods it. Okay, this is done. Good. Now I'm again not focusing on the whether PC6 receives and accepts it or PC4 discards it. I'm just focusing on the switch. The switch has received this frame. And now what does it do? It checks for it goes through the steps again, looks for the source address field, which is C. Great. Okay, it is there in the MAC table. Let's look at the port associated with the entry in the MAC table. It is having P3, already having P3, but now the frame has, with the source address C, has, instead of arriving on port 3, has arrived on port P4. So what switch will do is, it now understands, because of this frame coming on a different port, that most likely the PC has moved and hence the MAC has moved. So what it does is relearn the MAC C on port P4. And here in the MAC table, it will replace P3 with a P4 entry. Okay. And this is the concept what is known as MAC move. Okay. So to reiterate or repeat, the MAC move is the concept when the port number with the MAC address in the MAC table changes. In the explanation that I said, initially the MAC C was learned on port P3 and then on port P4. So that's the important point that one needs to remember. Okay, and again, as I said, I have explained this concept of MAC move using a simple topology. In real world, it might happen when there is a redundant path available between two switches. That is a more common scenario. But for understanding and explanation, if you use this method of explaining to anybody in the interview, this should be good enough. Because all they are looking for is how solid are your fundamentals. So this should be good enough. Okay. Now the interview question that is most commonly asked is, they will ask you to draw a topology and explain the concept of MAC move. That's pretty much it. If you can do that, then you have nailed the question. Okay. In the next lesson, we will consider and discuss the concept behind why do we need the entries in the MAC table, the dynamic entries to age. Remember we said in the earlier lessons we discussed that anytime an entry goes into the MAC table, it has an associated timer with it. which is 300 seconds, and then gradually as it sits in the MAC table, the timer reduces by every second it passes, right? So we will understand why do we need the entries to get age, and if they would not age, then what would be the result of it.